Welcome. The purpose of this tutorial is to introduce you to the concept of using component blocks. During the tutorial I'll cover standard component blocks used for shading and reflection, adjacency, ground blocks to represent a ground adjacency condition, and finally adiabatic blocks to represent an adjacent condition with negligible heat transfer. Further information on the topics covered is available in the help file. Standard component blocks are simple objects that don't contain zones and can be used to represent surfaces which provide shading and reflect solar radiation during simulation. They're commonly used to model fixed shading on the building exterior, but can also be used to create fixed entities such as trees and other buildings nearby, which impact on the external conditions of the building being modelled. There are other ways of introducing fixed shading to openings which will be covered separately. You should note that including external objects in the model does have an impact on simulation time. Here we have a building which requires fixed shading in the form of a standard component block at roof level to shade the extensive glazing on the southern facade here. Select the Add Block tool and set the block type to Component Block. Where we can see we have three options available. Leave it set to Standard and leave the remaining options set to extrude the block using the rectangular perimeter shape. Now turn on increment snaps setting the increment to 0.1 meters. Move the cursor onto the roof surface until highlighted. Press and hold the Shift key to lock the drawing plane to the roof slope. Click on the end point snap of the southwest corner. Release the Shift key and use the increment snap and drawing guide to draw the 1.5 meter wide full length base for the block. As the block is not horizontal, the extrusion distance must be defined. Move the cursor vertically upwards and type in the dimension to set the height to the minimum block height of 0.01 meters. Press enter to create the block and cancel the add block function. The light purple colour indicates that it is a standard component block, which now appears as Component Block 1 in the navigation panel. Component blocks don't provide shading and reflection unless the option is checked in the Component Block section of the Construction tab here. This is selected by default. As discussed earlier, we can also use component blocks to model the shading and reflection effects from adjacent buildings and other objects such as trees. More detail will be provided on this in the model data tutorials. I'll now represent a larger building to the west of our building with a standard component block. Go into the Visualization tab. We can quickly see the shading effect due to the adjacent building. An adjacent condition represents the physical properties on the other side of a surface which impact on the heat transfer through that surface. Designbuilder automatically calculates adjacencies between blocks and zones, and the default settings can be overridden at surface level by data entry if desired. The mechanisms for changing adjacent conditions in this way will be introduced in later tutorials. This tutorial will concentrate on drawing the geometric objects which enable the adjacencies to be automatically set correctly. Ground component blocks are used as a convenient way to set the adjacency condition of an external wall where all or part of that wall is in contact with the ground rather than the ambient air. Note that Designbuilder automatically assigns ground adjacency to any block drawn below ground level, such as a basement. There is no need to add ground blocks in this situation. We'll assume that our building is constructed on a sloping site and that the ground level at the rear or northern side of the building is 0.3 metres higher than the front southern side. To represent this, we can draw ground blocks. Select the Add Block tool, change the component block type to ground, change the perimeter wall type to polygon, and leave the line type set as straight. Now zoom into the west wall to enable easy location of the end snap points. Cancel the zoom command and move the cursor onto the west wall until highlighted. Press and hold Shift and click on the end point snap on the bottom northwest corner. Release the Shift key, move the cursor vertically upwards and either enter the length or use the increment snap to set the line height to 0.3 metres. Move the cursor to the southwest corner and click on the end point snap. Move back to the start point and select this to confirm the perimeter of the block. Move the cursor an arbitrary distance from the wall and left click to confirm the depth of the green ground block. Note that the depth of the ground and adiabatic component blocks is not important, ignoring minor effects due to solar radiation reflection, and they will perform their intended function regardless of block height or depth. The key criterion is that these blocks are in contact with the external wall over the required surface area. I now zoom back out using the Fit to Screen tool and rotate the view to enable me to add the 0.3 metres high block to the northern facade. This time I can use the rectangle option. Note again that the component blocks are shown in the navigation panel here, which does not differentiate between the block types. Adiabatic component blocks are used to represent adjacent buildings which are directly coupled but which do not form part of the building being modelled and which operate at approximately the same temperature as the model building. There is no heat flow across an adiabatic surface, which represents the absence of a temperature differential and the insignificant heat transfer between the buildings. We'll assume that our building is semi-detached or directly coupled to another building, conditioned to the same temperature. and that the east wall is a party wall. I'll draw an adiabatic block to represent this. Rotate the view to enable the east wall to be used as the drawing surface. Select the Add Block tool. Change the component type, block type, to adiabatic. Change the perimeter type to polygon. And leave the line type set at straight. Move the cursor onto the east wall until highlighted. Press and hold Shift. Click on the endpoint snap on the bottom southeast corner. Release the Shift key and trace around the perimeter of the wall using the end point snaps. Move the drag face cursor away from the wall and left click to confirm the depth of the adiabatic block. Cancel the add block function. The adiabatic block is a dark purple colour and is again shown in the navigation panel, this time as component block 4. Where the building perimeter shape is not uniform, it's useful to be able to check that the component blocks drawn are fully adjacent and have created the ground or adiabatic adjacency condition intended. We can do this by going to zone level, where the green markers indicate the surfaces on the ground floor and the north and west walls with ground adjacency, and the red marker indicates adiabatic adjacency on the east wall. Using the navigation panel, we can view the breakdown of each surface if desired. For example, the north wall includes the ground adjacency indicated by the green text of 5.824 meters squared. We can also see that the surfaces in contact with adiabatic blocks, such as the east wall here, are coloured red in the navigation panel. Further information on these topics can be found in the help file and other tutorials.